Hello again, this is Ms. Nakayama. Today's lesson is 7.1 polygons. So we have more definitions, not nearly as bad as what you had in the last chapter. But first off, a polygon, that is the wrong pen. A polygon is a closed plane figure formed by three or more segments. Okay, you can have an equilateral polygon where all the sides are equal. You can have an equiangular polygon where all the angles are equal. If you have a regular polygon, then we know the angles and the sides are both equal. You need to know what consecutive vertices are. Consecutive vertices are the vertices that are at the endpoints of the same side. So looking at this diagram, whenever you name a polygon, you have to name it in consecutive order. So this is called polygon A, B, C, D, E. That's consecutive. You could name it polygon C, D, E, A, B. You could name it polygon D, C, B, A, E. It does not matter where you start. It does not matter if you go clockwise or counterclockwise, but you have to use consecutive vertices. So you cannot call it A, C, E, B, D. Have to go in order. And a diagonal, last but not least, important, a diagonal is a segment that joins two non-consecutive vertices. So you can see in this picture, segment BD and segment BE are diagonals. Okay, so first off, the interior angles of a polygon interior angles theorem, they always add up to n minus 2 times 180, which it says right here. And if you were to do this several times, this right here is a 1, 2, 3, 4, 5, has 5 sides to it. And when you draw the diagonals from one point, the possible diagonals, if you notice I have 5 sides, when I draw the diagonals, I now have 3 triangles. So always you have, remember 180 degrees add up to how many is the sum of the angles of a triangle, and how many triangles you have is always going to be the number of sides minus 2. This one was 5 minus 2. If you think of a rectangle, it is 4 sides minus 2 is 2 triangles. So if you were to draw a diagonal, then you would have 2 triangles. So a quadrilateral, it's easiest just to remember that it always adds up to 360. Okay, we have the exterior angles theorem of polygons, and the exterior angles, we've already talked about what they are. They always add up to 360. So it's a lot easier to remember and deal with than this formula up here. And if you have to find one interior angle or one exterior angle, then you're going to take those formulas and divide by n, because n is the number of sides. So I know you can tell me which of these is easier to deal with, because which one's simpler. All right, and you're going to see as we go through it. You do need to know the names of common polygons. 3, you know, is a triangle. Most people don't say trigon. 4 is a quadrilateral or a tetragon. Again, most people don't, but when you get into 3D, they do. 5 is a pentagon. 6, hexagon. 7 is a heptagon, also sometimes referred to as a septagon. 8 is an octagon. 9 is a nonagon or enneagon, if you know anything about enneagrams. 10 is a decagon. 11, hendecagon. 12, dodecagon. And then we also have a common one, icosagon. And that is 20 sides. But generally, if it's over 12, you can just say n-gon. So you could also say 20-gon. All right, so let's look at our examples. Name each polygon by the number of sides and classify each polygon as equiangular, equilateral, regular, or irregular. So on this first one, when you're doing these problems, y'all, I'll encourage you just put a dot at whatever spot you want to start counting, because sometimes it's hard to remember. So that's 1, 2, 3, 4, 5, 6. So I have 6 sides, so that makes this guy a hexagon. And these symbols tell me that all the sides are equal, and these symbols tell me all the angles are equal. So if all the sides and the angles are equal, it's a regular hexagon. All right, number 2. easy to count, that has 4 sides, so it is a quadrilateral. There are no markings telling me anything about the sides or the angles, so it is irregular. Next, we have 5 sides, and 5 sides is a pentagon, and they tell us we have tick marks on each of the sides, so that tells us that all the sides are equal, so it's an equilateral pentagon. And last but not least, I'm going to start with whichever side you want to start with counting. So 1, 2, 3, 4, 5, 6, 7, 8. 8 sides is an octagon. And an octagon, it has all the angles equal, so it is equiangular. I don't know what that is. Okay. Find the sum of the measures of the interior angles of the following figures. So you have to know this formula. Easiest way to learn it, y'all, is to write it down every time you do a problem. But the sum of the measures of the interior angles is n minus 2 times 180, because that's how many triangles are inside of it. If it's an 11gon, then I know that n is 11. So in my formula, I'm going to put 11 in for n. 11 minus 2 times 180 is 9 times 180, which is 1620. All right, number 6. I'm going to start here to count the sides. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in my formula, I'm going to have what minus 2 times 180? I'm going to have 10 minus 2 times 180, which is 8. That means if I were to start at one vertex and draw the diagonals, I would have 8 triangles inside there. 8 times 180 is 140 degrees. Then we have a heptagon, so you've got to know the name. Number 7 is a heptagon, and that means that I have n equal to 7, because I have 7 sides. So in my formula, 7 minus 2 times 180, 5 times 180 is 900. So the sum of the measures of the interior angles is 900. All right, look at number 8. The sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. So this is using the same formula we just talked about. 1800 is equal to n minus 2 times 180. So the easiest way to solve that, y'all, is divide both sides by 180. So 10 is equal to n minus 2, and then I'm going to add 2 to both sides and get 12 equal to n. And if I have 12 sides, it's called a dodecagon. All right, number 9, 3240. Again, that's equal to n minus 2 times 180. I'm going to divide by 180. So 18 equals n minus 2. I'm going to add 2. So I have a, y'all remember that word up there? Icosagon, or you could say 20-sided polygon. 20-con. Okay, number 10. Find the measure of one interior angle in a dodecagon. So one interior angle, a regular dodecagon means n equals 12. We just did that in number 8. So my formula is n minus 2 times 180 divided by n, because I have 12 angles, same number of angles. Angles and sides are always going to be the same. So when I plug in 12 for n on the top and the bottom, 10 times 180 divided by 12 is equal to 150 degrees. That's all it is. Working with this formula. Number 11, find the measure of each interior angle of a regular polygon. No, the measure of each interior angle of a regular polygon is 165. How many sides does the polygon have? So if you take that formula we were just talking about, n minus 2 times 180 over n, and you're going to set it equal to 165. And you got to solve that. So I'm going to multiply both sides by n. Then I'm going to distribute my 180. So that'd be 180n minus 360 equals 165n. Then I'm going to subtract my 180n, get negative 360 equals negative 15n, divide by negative 15, and n equals 24. Now, some people mess this up. So I'm actually going to show you a shorter way. You may do it either way that you want, but I think it's easier if you remember from way back in the beginning that an interior angle and an exterior angle of a polygon are always supplementary. So they always add up to 180. So The other way to do this problem is to start with 180 and subtract that interior angle of 165. And then I'm going to get an exterior angle, which is 15. And what do all the exterior angles add up to? Well, they add up to 360. So I just have to do 360 divided by 15, and I get 24. So your choice, this way or that way. I kind of like that one. But you do whichever one you can remember and whichever one you can always get it right. Okay, number 12. Find the missing angle measures. So in this particular polygon, I need to, first and foremost, I need to go find the sum. So how many sides do I have in this polygon? I have, if I start up here at X, so that's 1, 2, 3, 4, 5, 6. So that means N is 6 in my formula. 6 minus 2 times 180. 4 times 180 is 720. So I know that all of these numbers are going to add up to 720. So I'm going to write that out. So X plus 145 plus 115 plus 124 plus 111 plus 118 equals 720. And when I add up all those numbers, I'm going to get 613. So X plus 613 equals 720, and X equals 107. Okay? Number 13, same thing. I've got to find the sum first. The sum for 6 sides, y'all, we just did that in number 12. So I know the sum is 720. And this one, if you notice, I have 4 angles that are the same and 2 angles that are another one. So it's going to be, you can write it all out if you want to. It's easier to write 4 times 7x plus 2 times 4x because I have 4 set angles that measure 7x and 2 angles that measure 4x. And that's going to add up to 720. How many x's? 28 plus 8, 36x equals 720, and x equals 20. So they did ask us to find the measure of the angle. So if you go back up here, 20 times 7, these angles are all going to be 140. And these angles are going to be 4 times 20, which is 80. So that's number 13. On to number 14. Okay, that's a quadrilateral. So you shouldn't need the formula because it's easy to remember. It's just 2 triangles. So I'm going to do 120 plus 85 plus 53 plus x is equal to 360. When I add those up, I get 258 plus x equals 360, and x equals 102. All right, those were all interior. These are exterior. So the exterior, like I said, can be a little bit easier. Regardless, I know that all the exterior angles always add up to the same number, so it's a little bit easier to deal with. So I'm going to take 5x plus 58 plus 41 plus 69 plus 35 plus 62, and that equals 360. Add those numbers up. 5x plus 265 equals 360. 5x equals 95, and x equals 19. Number 16. Again, I'm exterior. They all add up to the same thing. So y plus 2y plus y plus 2y equals 360. 2, 4, 6y equals 360. And y equals 60. Number 17. They're only showing me one angle here, but they're telling me that all the sides are the same. So how many do I have? 1, 2, 3, 4, 5, 6. So I'm just going to take x has got to be equal to 360 divided by 6. So x is equal to 60. All right. Find the measures of each exterior angle of a regular 20gon. That's just like this one. So I'm just going to take 360 divided by 20, and I'm going to get 18 degrees. Number 19. The measure of an exterior angle of a regular polygon is given. Find the measure of the interior angle, then find the number of sides. So as I told you, this is the easier way to do these problems. This is the exterior angle. All right, if that's the exterior angle, then I'm going to subtract it from 180 to get the interior angle of 140. Forgot my little degree symbol, 140 degrees. Okay. Find the measure of the number of sides. Again, you can go through that more complicated formula, but y'all, if I know an exterior angle, it's just 360 divided by the measure of that angle. And so that means I have 9 sides. I think that's a lot easier. All right, last problem. In a coordinate plane, the sides of a polygon can be represented by graphs of linear equations. The vertices occur where the graphs intersect. You can find the coordinates of the vertices algebraically. So it is easiest to do it from the graph. If you look at this graph, I'm going to label this point A, this point B, and this point C. And because they actually cross at nice integers, then it's easy to find that answer. So from my graph, I know that A has the coordinates -2, 1, B has the coordinates 2, 3, C has the coordinates 0, -1. But just in case you have a problem like this and you cannot see it from the graph, I want to remind you that you can find how to find it algebraically. So if I'm going to go find this point of intersection, then I'm going to go find the point of intersection of this equation and this equation, because where those two meet is point A. So I'm using y equals -x minus 1 and y equals 1/2 x plus 2. If you remember way back when, you use either substitution or elimination to solve this problem. I'm going to use substitution because they're both equal to y. So I'm going to set -x minus 1 equal to 1/2 x plus 2. If you add x, I get add x and subtract 2 is going to give me -3 equals 3/2 x. And I'm going to multiply by the reciprocal of 3/2, which is 2/3. And that's going to give me -2 equal to x. And then you take that and you plug it into either one of these equations up here. Well, which one looks more fun to plug into? I think this guy does. So I'm going to use him, and I'm going to go plug in -2 for x. So y equals -2 minus 1, which is going to be 2 minus 1. So y equals 1. And if you see, that's exactly what that point is right there. So that is all we have to the angles of polygons, and then we talked about interior and exterior. Thank you so much for watching, y'all. Please don't hesitate to email me or come see me if you have any questions. Y'all have a great day.